Welcome, this is my first CFD simulation in my channel. Our first basic CFD simulation is a laminar flow, and you can just read out the problem specification given there. And now, the first part I'm gonna do is geometry 1. So, you can see the geometry of length 3 meters and diameter of around 0.2 meters, and you have to remember those things like density and viscosity, and there is a constant velocity of 1 meter per second. So now we are going to do this simulation in my in workbench of ANSYS, and now I have ANSYS version 19.2 with me. So this is the latest one which we have right now. So it is taking some time to open. So CFD is a very powerful tool for engineers. It might be any stream of engineers, they'll have CFD, except for CSC or IT. But then CSC guys, they can help out with coding this CFD in a better way. But then they need some basics of fluid dynamics and computational methods. So now we're gonna look for component systems. So if you can't see as many as I have, just go to Wave and click on that tick mark. So then you can see what all are available in the ANSYS 19.2 version. Now we're gonna drag this geometry icon to our project schematic. So if you can't see these properties which I have, just right click on the geometry and click on the properties so you can see them aside. So now we are going to make a 2D analysis, because in this we are just looking for velocity profile or the pressure distribution in a pipe. So to visualize it, anyways, we're gonna create a plane and then at its central axis and then see the results, and rename this geometry as a pipe. And the geometry will be done in design modeler generally. Even you can choose space climb, but I think many of them may not have this latest version of ANSYS, so telling this in design modeler. So as our thing is a 2D one, click on the XY plane and click on that icon what I have clicked, and then go to sketching and then click onto the rectangle one. Before that you have to check whether the units are in meters or not, and in degrees also. So then click on the rectangle, and from its center of the coordinate system draw the rectangle. I'm zooming it because the ruler you see is around 10 meters, but then our dimensions are 0.2 meter diameter and 2 meters of length. So to have the dimensions, I'm clicking on the dimension and then clicking on general, and then just editing the numerical values which are associated with vertical and horizontal line constraints or maybe dimensions. So after doing it, we have done only line sketching. So we have to make a surface from the lines, or else if you have many sketches from different planes, just make a line from that. As I show, you have to go from concept, then line from sketch, and just click on the lines which you want. But then we don't want lines because we already have lines. But then click on the surfaces from sketches and click on any of the line from your sketch and then generate your surface. You can see your surface. Why we are doing this is because of we are doing 2D analysis and we need to have a 2D structure but not a line. After doing it, click on the part 1 body and then on surface body and click on the fluid, because our domain gonna be fluid but not a solid. After clicking it, click on the generate, and now we have to name the sections, named sections. So click on to the first vertical line near to the center of the coordinate system and name it as inlet, and the line which is far away 3 meters, name it as outlet. So why we are doing these name sections, I will tell you later. And click on the top and bottom lines which you see and name them they name them as wall. Okay, everything is done. So click on to the face surface selection. You can see up right there which are associated with the green colors. So why we are doing this name selection is because we'll have an inlet and outlet and the walls. So we define the boundaries there. So as I said earlierly, so you have to click on the face surface and then click on the surface of your geometry and then name that selection as fluid domain. We're naming it as a fluid domain because the fluid flow will be there in this domain, and then just cross check all these things and then save your project where do you want. So I'm saving it in documents with named as laminar. Oh, no, something you can just name it as randomly, but then I want to name it as laminar flow in a pipe. So this is a basic geometry thing. So why do we divide these things as like this? Because generally you need to adapt to this type of structure of program schematic. For the bigger problems, it takes a lot of time to create the geometry and meshing and even for the results. So you need to save them such that each and everything is getting divided like this with component systems.